Today we're going to talk about lesson 2-5, testing equivalence. The big idea is you can test whether an algebraic expressions are equivalent using substitution, tables, graphs, or your properties. Now, what's going to be common and what you're going to like to see is we're going to look at graphs and tables especially because our calculator is going to do a lot of the stuff for us. You can use substitution by just putting in random numbers and making sure that it works, okay? And you're going to find out these three things right here are going to be far easier to do than your properties, but you can also show on your properties by just doing it the long way and showing that they are equal, okay? So we're going to talk about those four things, and all they're going to show is if your expressions are the same or if they are different. Okay, equivalent or not. So if you look at example 1, it says test whether 4n plus 2n times the quantity n minus 1 and n times the quantity n plus 1 plus n plus 1 are equivalent. If you use the table, as I've wrote here, then y1 and y2 values have to be equivalent for all your x values, okay? They have to be equivalent for all your x values. That means no matter what you put in for x, both the y2 and the y1 on your table have to be the same thing, and I will show you that in just a little bit. If you use the graph, then the graphs have to lie on top of each other for all x values. So you need to make sure that there's nothing else. Make your window big enough and just make sure that they lie on top of each other. Okay, so I'm going to bring up my calculator here. And all you do is simply hit y equals. And what you're going to do is you're going to type that exactly how it is in on your calculator. So 4, instead of n's, we have to use x's. X plus 2 times x times the quantity x minus 1. Close your parentheses, hit enter, and you're going to type this one into your y2. So x times quantity x plus 1 plus x plus 1. Okay, now if I hit second function graph, that means my table pops up. You need to look at some negative values, as I've told you many times before, as well as you need to look at some positive values. So as you look through these negative values, you can tell your y1 and y2s are the same thing. No matter what I put in for my x, I always get out the same thing. When x is 9, and you get out 180, so on and so forth. So if you just scroll here and it looks like all those are the same thing, you know this thing is, they are equivalent. How can you tell looking at your graph? Well, same basic deal. If I hit graph, and I'm going to go to Zoom Z Standard so I can look at my standard viewing window. But if you look at your graph, it's just one parabola, okay? Since it's just one parabola, that means it probably lies on top of each other. Therefore, by looking at this graph, they are equivalent. There ain't something else over here, okay? If there was, then we'd have to say not equivalent. But these appear to be equivalent. So let's look at example 2. It says a common error that some students make is to think that 4x minus x is equivalent to 4 for all values of x. Here are 3 ways to show that these expressions are not equivalent. Okay, we're going to graph these. Okay, So that's going to be one way. So they say 4x, let me clear that out, 4x minus x is the first one. Okay. And the second one is 4. It's equivalent to 4 at every single time. So if I hit graph, if I hit table, as you can see, when x equals 11, our first one equals 33, and our y squared, or y sub 2, our second one, equals 4. Well, does 33 equal 4? No. Therefore, by looking at that on the table, these are not equivalent. Because I found an x value that's a counterexample where it won't work for. Where was that counterexample at? Well, there's a bunch of them right here, right? But at x equals 11, it doesn't work. Okay? What's the other way? Well, I could show the graph. Okay? If I hit graph, here's my first equation, 4x minus x. Okay? Here's my other equation, y equals 4. It's 4 at all the time. Okay? Is there a point where these two things are equal? Yeah, about right here. And I could scroll up to that. So it's not like they're never equivalent. They're actually equivalent at what we would say is roughly, I don't know, 1.5, right in there. Okay? But they are not lying on top of each other. Since they're not lying on top of each other, these things are not equivalent. They might be equivalent at one point right here, but they're not equivalent anywhere else. So there's the second way. Well, what's the third way? Well, you can use your properties, okay? And this is just basically knowing your math. We know that 4x minus x, like terms, correct? Well, what's 4x minus x? Well, 4x minus x is 3x. Okay? You got 4 girlfriends, you subtracted a girlfriend. You're left with 3 girlfriends. Does 3 girlfriends equal 4? No. Okay? How do I know that? Well, if I say x equals 2, 3 times 2 is 6. Does 6 equal 4? No. So there's another way to show that they're not equivalent. This is what we call using our properties. Okay? Moving on, example 3. Are a negative x squared and the quantity negative x squared equivalent expressions? If so, explain. If not, provide a counterexample. Okay? So I go to my calculator. And I always like using the table. That's just what I'm comfortable with. You can use your graph. But when you have to show a counterexample, a lot of times a lot of people use the table because it's a lot easier to find a number that doesn't work. So I type in a negative x squared. That's my y1. My y2 is the quantity negative x squared. Okay? So I'm going to hit second function graph, look at my table, and as you can see here, since my table was clear up here in the positives, we already found a counterexample, correct? Okay? When x equals 3, the first one equals a negative 9, the second one equals a positive 9. Does a negative 9 equal a positive 9? No. So, what you can say is, when x equals 3, a negative x squared equals a negative 9, and the quantity negative x squared equals a positive 9. And there's my counterexample stating that those two things are not equivalent. Let's look at example 4. Use properties to show that these two things is equivalent to these two things, or that whole thing. So go to our calculator again. Y equals. You also have to be careful when you type this stuff in. So quantity 2x squared plus 3 minus 8 times the quantity 3x squared plus 4. Close the parentheses. My y2 is going to be 1 minus 27x squared minus 30 plus 5x squared. I'm going to hit second function table because that's what I like to use. But if you look here through the positives, looks like they're always the same. Notice I got these negatives, negative, 18, 11, blah, blah, blah. A lot of times what you want to do is you want to check negative numbers as well, because sometimes negative numbers throw a wrench in everything. But if you look at those appear to be all the same thing. So as I scroll through here and I look, it appears that they are equivalent. So based on numerous negative and positive x values substituted in, we assume these expressions are equivalent. All right? Very easy, very fast. Can do it all on your calculator. Thank you very much. We'll see you tomorrow.